Hi everyone, welcome to another episode of Hands On with AI Agents. And in this episode, we're going to be talking about an agent for brand search optimization. And the cool thing is, this even includes a computer use subagent. Let's talk more. Hi, Nikhil.
Hi Sita, thanks for having me.
So, what even is a brand search optimization agent?
Brand Search Optimization Agent is an agent that automates a search engine optimization workflow. And for a given brand, it tries to optimize the titles of the brand given a comparison between the top search results for a set of keywords. So it will find out the keywords, find out the top search results for those keywords, and then compare and contrast and give you an analysis of the titles you should be optimizing for your brand.
Sounds wonderful. Let's jump into it then. I'm guessing we're going to be using ADK here. No surprises there.
Yep, we are using Google's recently released agent development kit.
So, let's go into the architecture then.
So, talking about the flow, um, a search engine optimizer, particularly working with the brand, is concerned about showing their brands at the top of the search results for a set of keywords. So, in this workflow, given a brand name, what the agent does is it finds out the keywords based on the titles, description, and attributes from a BigQuery table. That's the step one. And once it finds the keywords, it then uses the top keywords from the list and then uses a web browser agent to search for those keywords on the web. In this case, I'll be showing Google Shopping as an example and gets the titles of the top products from the web page and then compares them with the products and titles coming from BigQuery. The analysis and the comparison then yields a report where you can see the comparison side by side with the titles of your brand versus the top brands. And then you can find out insights like what are the missing keywords, what extra information needs to be added so that your brand comes at the top for those search keywords. Okay, so now that we have seen the flow of the agent, let's move to the architecture. And as I talked about in the introduction to the ADK, we have different tools and subagents here. On the left, you can see there is brand search optimization route agent. The main job of this agent is to route you to different subagents. And we have three subagents here: keyword finding agent, search results agent, and comparison route agent, which again connects to two more subagents. Starting with the keyword finding agent, we have tools such as BigQuery and connecting and getting data from BigQuery. So this tool lets you send the brand name and get the title, description, and attributes from a BigQuery table. And then the LLM behind the scene, Gemini model, will find out the keywords based on the titles, description, and the attributes that we got from the BigQuery. So this agent ultimately gives you a list of keywords and then also lets you choose top keywords based on some criteria, and you can change that in the prompt. The next agent is the search results agent, which has tools such as going to URL, finding elements, scrolling down, and getting the page source. And from the tools, you can guess this is the web browser agent. And behind the scene, it uses Selenium and WebDriver. So what this agent will do is take the keyword and then search for the keyword on a website, say Google Shopping, and get the top three results for that keyword, and save the titles of the results for the next step, which is comparing with your own brand's title. So coming to the next agent, we have two parts: the generator and comparator. The generator will compare and create a report of what the new titles should look like by comparing with the top search result titles. And the critique will then improve on the comparison to give you a better report. And this is where you as a company can also introduce your policies and if you have specific rules. So ultimately, the comparison root agent is where we stop and get a report. Any questions here?
Yeah, and when you're building this multi-agent, how do you decide between which of these functions should be a sub-agent? Like, how do you scope each of these sub-agents?
That's an excellent question, Sita. So this is very similar to software development, where we divide a multi-agent system by its specialties and expertise. So sub-agents should have their own specialties. In this case, keyword finding is one of the tasks that the multi-agent system does. So it's natural for it to be a sub-agent. What it does is it also handles the complexity and breaks down the tasks, similar to software development. It lets you expand the reach and capacity in the future. If you want to have more complex keyword finding agent, you can replace this sub agent with something more uh, complex. And it also increases the robustness and flexibility of your overall system. So web browsing is divided, keyword finding is in its own a sub agent, and also comparison is a sub agent with its output as a report.
Sounds good. And I've also wanted to ask you, why did we not use a web scraping API as an agent, and why use a computer use agent here? Like, what's the need to you to open up a new tab or in a browser?
Yeah, that's excellent question. So web scraping is a natural way to think about getting data from web pages or HTML content. But nowadays, modern websites load the data dynamically when the initial page loads. So there is some JavaScript code that adds more dynamic elements. So what Selenium or web browser based agents do is they'll let you open a web browser, and then they can see the dynamically loaded content as well. And there are some websites which need user interaction, complex user interactions to access the data. For example, clicking on some start button or scrolling down the page to actually see the content. So the web browser based agents, as opposed to the scraping ones, will let you do that as well. And there are more advantages such as getting over anti-scraping measures, extracting data from elements that are not directly in the HTML source, and also navigating complex website structures by mimicking the real user behaviors. So overall, there are advantages of using a web browser agent based on Selenium or web drivers versus just using a web scraper.
And now I guess it's code time. Can you show us how to implement this architecture?
Absolutely. So before we dive into the code, let's look at the README and the setup needed to get into the multi-agent setup. So this agent needs BigQuery setup with a table setup with the sample data. So there are some instructions in the README, and as you follow the instructions, you'll find that there is a run.sh script inside the deployment folder here, and this needs to be run to set up the BigQuery table with sample data. What it does is it first installs all the requirements with Poetry install, and then populates the BigQuery table with sample data. And if I go inside this Python file, you can see this is the sample data we will be working with. There are titles, descriptions, attributes, and brand, and it creates a data set if it doesn't exist and populates the BigQuery table. And once this step is successful, what you should see on the GCP side is this table with the title, description, attributes, and brand. Any questions on this?
And even if someone doesn't use Google Cloud or BigQuery, they can still use this agent by swapping out this particular component, right?
Yes, that's absolutely right. Uh, BigQuery is just one of the multiple options you can use here. And later on, I'll be showing how to use your own database client and then swapping out BigQuery with your own data set. Um, and it's fairly easy to do that. You just need to change a Python function and pass in the brand name to it and get the same data as the BigQuery. So With that, let's jump onto the main agent here. It will be under brand search optimization package, under the folder brand search optimization. And when you look at the agent.py, this is our main agent, the root agent that does the routing. It's 38 lines of code. What it does is it has sub agents defined. As I said, keyword finding, search results, and comparison. And it has its own description. So when I click on the root prompt, you'll find the prompt it uses, and the description is here, a helpful assistant for brand search optimization. When you look at the prompt, the root agent prompt gathers the brand name, then follows a series of steps by finding the keywords, searching the keywords on web, and then transferring it to the comparison root agent, which has two more agents behind the scene. It has some constraints, and it needs to complete all the steps. So this is one way to achieve a series of workflow steps. Another way to do this would be to import sequential agent like this, google.adk.agents or sequential agent, and then use the sequential agent to do the same steps. But for now, what I've done is I've used prompting to achieve the same goal. So with this, let's jump on to the root agents. The first one is keyword finding. And the main function of this agent will be to find out the keywords using Gemini's inherent capabilities to understand the titles and descriptions to come up with keywords for a blob of text. So what you can see here, it uses a tool, and this is the tool I was referring to earlier. This is the tool you'll need to replace if you're not using GCP or BigQuery. What this tool does is it initializes a database client and calls the database client with a SQL query. This is constructed uh, dynamically given table ID, dataset ID project, and these will come from your environment file. And for a particular brand you're looking for, and you can configure it to have more than three as well. Right now it's limited to three. It will run this query job, get the results, and then transform the results in a markdown table like this. This is a formatting that we've been working with. You can also have your own formatting if you prefer anything other than markdown. So the output from the keyword finding agent is a list of keywords. And if I go back to the prompt, here you can also see that I'm asking it to remove the duplicate keywords and group them with similar meaning, and rank them based on some criteria I've mentioned here. So generic keywords are ranked higher, so that um, your brand comes up at the top for generic keywords, which are more common and frequent. And you can also define your own criteria here to group and rank the keywords. So this is the step one, and we'll be moving to the web browser agent in the next step.
And how are you passing the input to this agent? Like, does it come from the root agent?
That's a very good question. So yes, so if I go back to the root agent, you can see that it takes the keywords from the keyword finding agent and passes it to the search results agent. For the debugging purposes, what I've done is I'll have also let it use a user inputted keyword. So there are two modes. It can either take the keywords from the keyword finding agent, or it can also ask the user to search for a keyword. So you'll see the output of all the keywords when this step finishes. You can pick a keyword from that list, or it will pick the top one from the earlier agent. So moving on to the search results agent, this is the agent that does web browsing. And I'll start with the agent definition at the bottom. You can see that it has a list of tools which are going to URL, taking screenshots, finding elements, and so on. And what they do behind the scene is they call the Selenium actions. And there is a wrapper tool which is analyze web page and determine action. And this is used when the task at hand is a bit more complicated. So there are some atomic tools. Let's look at them one by one. First one will be go to URL. It uses the driver object and gets the URL and navigates to the URL. Taking screenshot takes tool context, which is a short-term state that ADK maintains across tools, takes this as input and saves the screenshot with a file name. And then this is later used as an artifact by the other tools and agents. Click at coordinates is self-explanatory, takes X and Y coordinates and then finds the element and then clicks on it. Finding element with text needs the text pattern, and it finds the element in the driver object, and it also throws more meaningful errors if it cannot find the element you're looking for. Clicking with text again takes a string and then finds the element by the pattern and then clicks on the element. Enter text into element is one that this particular workflow will be using because we'll be doing searching with the keyword on the website. So text to enter will be our keyword, and element ID will be the search bar and the ID associated with the search bar. What it will do is enter the text into the search bar and then enter send the key for send the keywords for searching. Scrolling down might be needed for our agent based on the website we visit. For the Google Shopping example, I've seen the agent scroll down one or two times, but the agent decides when to scroll down on its own. So this is also a useful tool. Getting page source is the most important tool of the brand search optimization agent because it relies heavily on the page source. And then uh, to get across some of the limits, I have put in a hard-coded limit here, which you can change later on to a different value. So what it does, it gets the page source, and if you limit the page source, it will automatically complete the rest of the page source. And if the page source is less than the limit, there won't be an issue. Analyze web page, as I said earlier, will determine the series of steps that are needed to achieve an end goal. So in this case, the end goal is to find out the titles of the top three products. So given a page source, what this tool does is it passes the page source to this tool, and then it also gives the task. So user task is also an input, and then finds out a series of atomic steps the agent needs to take to achieve the goal. So in this case, if the goal is to find out the titles of top three elements, it can decide to find the search bar, enter the text in the search bar, scroll down if needed, click on some buttons if needed, and then find out the top three search results from the source and get the titles of those search results.
No, this is a detailed walkthrough, Nikhil. Thank you. So basically, we've seen two steps until now. The first one is where the subagent actually identifies the keywords, and the second one is where it uses the keywords identified to perform a computer use triggered search. And the root agent can actually use these subagents and the tools within the computer use agent as and when it decides to, right?
Yes, that's the overall flow. But behind the scene, what is happening is root agent is transferring you to the search results agent, and search result agent has these sub tools. So the tool usage is within the search result agent. So in this case, when a search result agent is triggered, you're still within the scope of the agent until the task is done. Once the task is done, you are transferred back to the root agent for the next routing, which is the comparison.
Sounds good.
So let's look at the comparison agent, and particularly when we look at the prompt, you can see that it calls the comparison agent and then critique agent. So there is a root agent which calls the comparison agent and then critique agent. So you can see the root agent is routing to the generator agent, which is this agent, then critique agent um, is called after that, and they loop through to find out the best comparison report. And when the comparison critique agent is satisfied, we relay the information back to the user. So now this is one way to achieve the looping, but ADK also has a built-in loop agent which you can import like this, and then use the loop agent instead of the standard LLM agent. But for the purposes of this demo, I've achieved this through a series of prompt instructions, and you'll see it in action in some time. Ultimately, what this agent does is first creates comparison between the titles of the brand and the titles of the top search results, and then compares and critiques them until it finds the best approach to improve the titles. And some of the brand owners might have their own policies which can go in the critique agent, or it could be related to a specific company or some rules. Business specific rules can also go in the critique agent, and that's why we have this here, so that it's not just the Gemini models coming up with the comparison. You have some rules in action to improve on the uh, Gemini generated comparisons or improvements to the title. So that concludes the agentic flow. What we have seen is three sub-agents: keyword finding, search result, and comparison. And ultimately, given a brand name, you get comparison between the brand's titles versus the top search results. So with this, let's move on to the evaluation. So brand search optimization also shows how to do the evaluation given eval dataset. And you can find that dataset inside eval folder under data. I have a sample run of the agent uh, from the beginning, where it asks for a brand name, to the final comparison report. And this eval set is then used by ADKs or agent development kits evaluation tool to do the evaluation based on the configs mentioned here. And this serves as an evaluation tool to find out how many tools were called and if the agent was able to achieve what it was meant to do. So to do this, we write this eval.py and import agent evaluator, and then invoke it like this: agent evaluator.evaluate with the module and the data file path. And the way to run this eval.py is under deployment and eval.sh, where you can find that there is a command line tool utility that comes with ADK to do ADK eval with the folder name, the dataset file, and a config path. So why is eval helpful in this case? Because we have so many tools, we want to make sure that the right tools are called for the right keywords, and the agent is taking the right actions. And once we make sure that it's working for a few queries, we can save those sessions and then use that to increase the robustness of our agent. So you can find out that in some cases the agent may not be calling the right tools. You can see that in this course and then improve on the prompt to ultimately make your agent more robust. So eval is very important when it comes to increasing the robustness and overall flow of the agent. Make sure for the eval you set the disable WebDriver to 1, because we do not need the WebDriver for this uh, evaluation, and we don't want the Chromium window to be open when the evaluations are running.
So basically, what we're doing here is we're evaluating the whole agent that we built using one of the sample conversations that you have here. And I have a couple questions here. Can you tell what if there's a CLI command, or how do we actually get one of the conversations into a JSON file? And secondly, the criteria that you show, are those predefined, or and can I define a custom criteria that can go in there?
So yeah, that's a good question. To get the evaluation data like I'm showing here, you need to open the web browser and go to the evaluation tab and save the session as an eval set, and that's how you get this JSON file. In the test config, you can come up with your own scores as well, but for now I've used the predefined criterias. So these are tool trajectory average scores and response match average scores.
Thank you.
Um, Apart from the eval, I've also included unit tests for the BigQuery data tool. I've mocked the BigQuery data with Magic Mock and tested out if the unit tests are covering the tool calling. And on top of it, you can also find an example interaction in a markdown format where you can see the end-to-end interaction of with a sample agent brand name with a sample keyword. So now that we have seen evaluation and tests, let's move on to how to run the agent on the web app. And what I'll be doing is I'll be showing how to set up the environment and then start the web app after this. So to start the web app, first what we need to do is to set the disable WebDriver to 0 after you've done evaluation and tests. Remember in the README, I've mentioned that this needs to be set to 1 when you're doing evaluation and unit testing. But for the web app, make sure this is set back to 0. And this is just an example, so you need to copy this file into .env and you'll be editing the variables in there. So with this, let me start the ADK web and make sure you're inside the brand search optimization folder. And what it does is it's running a web app in the background. And when you open this, you'll see a web browser. I'm going to minimize the code window. And here I'm going to select the brand search optimization agent. And I'm going to say hello. And as soon as I say hello, you should see another Chromium window pop up. And I'm going to minimize this for now, and then we can bring it back again when the agent needs to do web searching. So it's asking me for a brand name, and because we have used BSO test brand name for setting up our BigQuery table, we need to reuse it. So this is the brand name we'll be working with. What is happening behind the scene is the root agent is transferring the controls to the keyword finding agent, and you can see that keyword finding agent has been triggered, and inside the keyword finding agent we are calling the tool to get the product details for the brand. And when you look at the response coming from that tool, you can see there is a markdown table with the data, the sample data we had put in the BigQuery table. So the agent will also show the data in a markdown format here, and this is configured in the prompt. Um, you can see the title are short, the descriptions are not long enough, and attributes are not enough. And that's exactly what this agent is going to help ultimately for this brand owner. What it is going to do is, given the title and description, it's going to find the keywords, and then for those keywords it's going to find top search results, and then optimize these titles and come up with report that says you should add these keywords to the title and so on. So the Gemini's inherent capabilities are enough to find out the keywords for these titles, and these are the keywords that it has come up with, and they are running shoes, active shoes, sneakers, and so on. In the prompt, we had also asked the agent to group them by similar meanings and then rank them based on how generic they are. So this is the final list. The prompt is also set to find group the keywords based on their similarity, and later on I can show how to trigger the next agent. Um, so let me open the web browser agent, because this is the one that's going to be triggered now. I'm going to minimize this section. So from here onwards, you can set the agent to do the web browsing on its own. But for the purpose of this demo, I have made it so that it stops here and asks for my input. So I'm going to say looks good, and now it's transferring to the search result agent, and you can click on this detail panel to see if the transition has happened. You can confirm that it has happened, because now it's asking me for the website I want to visit, and I'm going to say Google Shopping. And after this, you can use the top keyword from here, or give a new keyword. So I'm going to say running shoes. And what that will do is it will take you to this URL. And it kind of happened very fast, but the agent searched for running shoes and then switched to Google Shopping. It's now getting the page source of Google Shopping and getting the titles of the top results. And looking at the results, what it has gathered is women's on Cloud Go from this one, men's Brooks Glycerin Max from this one, and A6 men's gel from this one. So these are the titles it has gathered from for this keyword. And in the next step, which also can be automated, but I've kept it to use the user input for now for the demo purposes. Um, what it is going to do is compare this with the titles we have got here, and then come up with some recommendations to improve the title, so that the brand search is optimized for these set of keywords. So if I say this looks good, so the transfer has happened to the comparison agent, and we don't need the web browser agent. I'm going to minimize this and see what is happening behind the scene. You can see the comparison generator agent is called, and it's ready with its report by going in a loop with comparison root agent to generator to critique. So if you look at the overall report, you can see that it has given very detailed report on what needs to be improved. So let's go one by one. Our brand titles were kids joggers, versus what we saw from Google Shopping was these. And let's look at the analysis and suggestions. Uh, it's saying your brand's titles are very specific. Google Shopping is generic. So suggestion is to specify joggers, sneakers, shoes, or keep it generic so that the products appear across generic keywords. Um, For this one case, it's missing gender, so adding gender will improve the search result ranking. Focuses on features or occasions, and Google uses model names. So these are the some of the suggestions, and there is improvement to add gender or running active keywords to the title. So this completes the flow from giving a brand name to finding the title, generating the keywords, doing the web browsing, understanding the titles of top results, and then comparing it with your brand. This could be a very useful tool in a for a day-to-day task of someone who is working on search engine optimization. So with that, let me show how to save this session as an evaluation set. So you can go to the eval tab, create evaluation set, give it a name, and then save it uh, for evaluation, and then use the eval.sh script to run the evaluation. So this concludes my demo. And what we have seen so far is what brand search optimization is. We went through the agentic flow, the architecture, the code, including the three sub agents, and one of them was web browsing agent. We looked at evaluation, testing, and an example through the ADK's web app. The example went through taking the brand name as an input and then creating the report.
Thank you, Nicole. Why don't you give us more resources on where we can find information?
So the brand search optimization is included as one of the ADK samples on GitHub. You can find it in Google's GitHub repository under ADK samples. You can find brand search optimization. The setup is mentioned in the README, and we are very happy to get more suggestions and contributions from all of you.
And thank you all for watching. We hope you liked this video. All of the resources mentioned in this video are in the description. Let us know what you think and what we should build next. Happy coding!